Welcome to Educator.com. In this first lesson for Algebra 1, we're going to be discussing variables and expressions. Before we do, we're going to talk a little bit about the history of algebra. And algebra was actually invented by multiple societies many years ago, as far back as the Babylonians 4,000 years ago. And the word algebra comes to us from an Arabic word, aljabar, and it's named in honor of an Arabic mathematician who wrote a math text in 832. And the reason algebra is important is that it allows us to solve real-world problems in fields like architecture, engineering, and science much more quickly than we could with math, with arithmetic. You could certainly use trial and error to make economic projections, but it would take a very long time. Algebra is much quicker and more efficient. So starting out with some definitions. First, what you'll see throughout algebra are variables. A variable is a letter of the alphabet that is used to represent an unknown number. And it could be any letter, but the most common ones that you're going to see are X and Y. So when you see these letters, it's telling you we don't know what this value is. It could be, and we can substitute in different values for X and Y, but when you're working with it in an equation, you can manipulate it using operations such as addition and subtraction, just like you did in arithmetic. Okay. An algebraic expression consists of variables and numbers that are combined using arithmetic operations. For example, an algebraic expression is 5x squared plus 2x minus 3. And what I have here are some variables, x squared and x. I have numbers, 5, 2, negative 3, and I have operations. Remember that operations are actions performed on numbers: addition, subtraction, multiplication, and division. And something you'll notice, though, is that we no longer use an x, usually, in algebra to indicate multiplication. And you can see how that would be confusing if we used x. Look at 5x squared. What I'm actually saying is 5 times x squared. But if I were to write that as 5x squared, that would be very confusing. Because is this saying times or is it another variable? Therefore, to indicate multiplication, there's a couple things that can be done. We can either put a dot, so you'll see this, 5x squared, or frequently, we just put the two numbers right next to each other, 5x squared. So 5x squared really means 5 times x squared. In this first example, we're going to take a sentence and write an algebraic expression for it. And it's a similar idea to writing an expression for a problem in using arithmetic, where no variables are involved. You take a similar approach. The first thing I'm going to do is look at what operation or operations are being performed. And I see that it says 8 less than the sum of the numbers m and n. Well, less than indicates subtraction. 8 less than. The temptation, though, is to write 8 minus, but that is incorrect. What this is saying is that I'm taking whatever comes after and I'm subtracting 8 from that. If I say that the number of apples that Justin has is 8 less than the number of apples that Haley has, I'm going to take the number of apples Haley has, say 15, and subtract 8 from that. Therefore, when you see something less than, and then a term or an expression comes after, you're actually going to put minus 8 after that second term. Okay, so I know that I'm going to have 8 less than this whole phrase. So let's go ahead and translate that phrase. The sum of the numbers m and n. Sum tells me I am adding. So I had subtraction, and now I have sum, so I'm adding. I have variables. M and n stand for numbers that are unknown. And I treat them the way I would a number, in that they can be added, m plus n. So this is telling me I have 8 less than, so 8 less than this sum, m and n. M plus n minus 8 is the algebraic expression described by this sentence. The second example is an example involving another algebraic expression, but this time with a product, so multiplication. The product of the square of x and the cube of y. So product is telling me that I'm going to multiply. And I'm multiplying two things, the square of x, so a variable, and the cube of y. Again, in algebra, we're going to avoid using an x to show multiplication because that's too confusing. If you're going to multiply in algebra, you simply use a dot. You can use parentheses, the two numbers in parentheses next to each other, or simply just put the two variables or numbers next to each other like this. Okay, so I have the product of the square of x. That's telling me I'm going to take x and I'm going to square it times the cube of y cubed. So this is x squared times y cubed. Or I could have even just left the dot out and written it as x squared y cubed with no dot in between. This one's a bit longer and more complex. Write an algebraic expression for the sum of 3 times a and 6 divided by the difference of 4 times f and 7 less than c. So let's take this one section at a time. This first clause before the comma is the sum of 3 times a and 6 divided by. So this entire first section is being divided by this whole second section. So I'm going to go ahead and write a fraction bar. And in the numerator, I'm going to have the sum of 3 times a and 6. Sum is telling me to add. So up here in the numerator, I'm going to be adding. And what I'm adding is 3 times a, multiplication, and 6. Okay, so I have the sum of 3a and 6. I'm taking that entire expression and dividing it by the difference. Difference tells me subtract of 4 times f and 7 less than c. So I am subtracting two things. The difference of 4 times f and 7 less than c. Okay. Difference is subtraction. So first I have 4 times f. A little more complicated over here because again we have that 7 less than c. Remember, 7 less than does not equal 7 minus. In fact, it's going to be something minus 7. What this is telling me is that I have c, and I'm going to have 7 less than that. I'm going to take 7 from c. When you're dealing especially with a more complex sentence like this, it's a very good idea to go back and double check your translation. Okay, so I had the sum of 3 times a and 6. That's 3a plus 6, that's sum, divided by. I'm dividing that sum by the difference of 4f, so 4f minus 7 less than c, which is c minus 7. So this expression, this is the algebraic expression for this complex sentence that we were given. In the fourth example, again, I'm talking about products, so multiplication. The product of 4 times x squared and 5 less than 2 times y. Product. So I'm going to be multiplying two things. I'm going to be multiplying two things. And I look at what I'm multiplying, and it's 4 times x squared. It's asking me to multiply that and, so I'm multiplying 4 times x squared and 5 less than 2 times y. 5 less than, we've got that by now, that I'm going to put the minus 5 last. Therefore, I have 2y minus 5. So it's 5 less than 2y. Going back, because even though this was short, it was somewhat complex, I'm going to go back and check this. The product of, so I am multiplying. And what I'm multiplying is 4 times x squared and 2 times y minus 5. Okay, today we introduced some definitions that are going to be used in algebra and talked about how to translate a sentence into an algebraic expression. Thanks for visiting educator.com.